All right, so example number 1, we have student council sponsored dance. So you realize that this is definitely not our school because apparently we're not allowed to dance here in Steinbach. Okay, Mennonite joke, let's go with that one there. So student council sponsored dance, the cost of a ticket is $5 and the cost of the DJ is $300. Okay, we want to write an equation for the profit, or P dollars, of the sale of tickets. Now when we do this, we can use either our variables here. Often I like to just use X and Y if I can as well, but we need to make sure we know what X and Y are. X is going to be the number of tickets sold. Okay, or this could be considered T, and Y is going to be the total profit of dance, also known as P. Okay, so I'm just going to use those as my variables, and I'm going to define them. This is what we call defining variables. We will do some of that now, and this year we're going to cover a little bit in these videos here, but it's important to make sure we define them. Next year and in grade 12, you're going to do a lot of defining of variables with your graphs, and so it's important that we do a good job of knowing exactly which is which. So I'm going to use X and Y just to make it a little bit simpler. So Y is equal to mx plus b. Y is our profit, just going to leave it as Y. Our slope is how things are changing. Well, the way our profit's going to change is based on the number of tickets sold. And for every ticket sold, there's going to be $5. So it's going to be 5 times the number of tickets sold. Okay, that's how we're going to find our profit. And then we have a expense of $300, so we have to subtract $300 from our profit. Now you'll notice, the 5 is our slope, okay? The negative 300 is our y-intercept, so that's where we're starting, at negative 300. Okay, 5 is slope, and negative 300 is our y-intercept. Now, we can graph this out, and I'm going to graph it out very simply. It doesn't actually ask us to, but I will graph it out. I'm going to put my x-intercept here in the middle. Okay, this is where y equals 0. And I'm going to put the x-axis and y-axis. I'm going to put the y-axis there. This is going to be y, this is going to be x. So y is the total profit. We need to go down, so negative 100, negative 200, and negative 300. And then this will be 0, and this will be positive 100, positive 200, positive 300, and positive 400. With the tickets, I'm going to go up by, let's go up by 50s. Is that a good number? Sorry, I just want to, where was the break-even point? So 0 plus 300 divided by 5. You know, let's go up by, yeah, let's do this as 50, 100, 150. It might work out, might not work out. I don't have my answer key in front of me today, but so there we go. All right, now when we graph this out, okay, you'll notice that we're going up by different values here than we are here, so we can't just use 5 being like 5 up and 1 across. Remember, if that's the slope, 5 would be a rise of 5, run of 1. We have to do things a little bit different. Our y-intercept is still 300, but now we're going to go up 5 for every 1. So if we go up 500, we're going to go across 100, and that would be our next point right there. We go up 500 across 100. We can just multiply everything by 100, and that gives us the same slope. Up 500 over 100, okay, as long as we're dealing with the same values, and then we can draw a line through. And you'll notice that apparently I could have made this, stretch this out a little bit farther, but that's okay. This is the point 0, negative 300, and this is the point 100, 200. So for 100 tickets sold, we would make $200. Now let's suppose that 123 people bought tickets. What is the profit going to be? Well, for this case here, we have our formula, 5x minus 300, and we're told that there's 123 people, or 123 tickets. That's our x, so we're going to put 123 into x. Y equals 5 times 123 minus 300. And if we solve for that, I'm going to use a calculator. 5 times 123 minus 300. We have a profit of $315, and that's our y value. Now we don't have that on here. 123 would be roughly there. We would actually. Is that 315? Oh, wait a minute. 123 would be about here. Yeah, there we go. That's about 315. Yeah. So that would be roughly on, we can see on our graph. So we would have a point right here of 123 and 315. That would be another point that would be on our graph. Okay, it's not on a nice line. Okay, because this is 125 is that nice line and 300 is that nice line. But it's we can label it because we know that that in fact is a point. What about the opposite way around? Let's say we have a profit of $350. How many tickets are sold? Well, on our graph, 350 is right here. So that's right about there. And if we go down, it'll be about 130 would be my guess. Let's see how close I was. We're going to use our exact same formula. Y equals 5x minus 300. But now we're told a profit. And we know that the profit is our Y value. So we're going to put 350 into our Y value there. 5x minus 300. Okay, and now we need to solve for x. Okay, to solve for x, we need to move everything else onto this side. We have a term right here that we can just automatically move over. And to do that, all we do is add 300 to both sides. So this becomes 650, and this cancels out. So this becomes 5x. So that's how we move that term over. This term here, we can't move over because it has an x in there. We want to get it all by the x all by itself. So we have to get rid of that 5. So we're going to divide both sides by 5, which will cancel this out. Now again, it's not 0, it's 1, but it gets rid of it, okay? Because 1 times x is just x. And so then we do 650 divided by 5 is 130. Wow, I was right on. And so x equals 130. So and this is the number of tickets sold. So we would say that 130 people, let's write this out a little better, 130 people bought tickets to the dance. Okay, so that's how we can kind of go, we can go through there and find that. So that would be this point right here. This is 130, 350. Whoops, sorry, you can't see that. Okay, that's that point right there, 130 and 350. When x is 130, our profit will be 350. All right, so that's how we can do that. Now, I just want to go through one other little problem here. Let's say that we have a profit of $146, or the question's asking, can we have a profit of exactly $146? Well, to do that, let's try to figure out how many tickets would be sold to get a profit of $146. So 146 is going to go in for y, 5x minus 300. We add 300 to both sides, same way that we did in part C. And so this is 446 is equal to 5x. We divide both sides by 5. And we're going to get x is equal to, 446 divided by 5, is equal to 89.2 tickets sold. Now, could the profit be exactly 146? Well, if 89.2 people bought tickets, it would in fact be $146 profit. We cannot sell part of a ticket. We can't sell part of a ticket. Remember, tickets just go in ones. Doesn't matter if you are a male, female, boy, girl, baby, doesn't matter. Tickets are still tickets. One ticket is one ticket, okay, at least based on this. So we can't sell part of a ticket. So a profit of $146 is not possible. Okay, because we can't sell part of a ticket. It would have to be an even number of tickets sold.